Imagine you've traveled farther than any human ever could, past every planet, every star, and every galaxy ever photographed. You leave behind the Milky Way, cross oceans of intergalactic darkness, and continue for billions of light years until you finally reach what seems to be the greatest frontier in existence, the edge of the observable universe. You expect to find a wall, a boundary, some final line where reality simply stops. Instead, you find something far more unsettling. There is no edge to stand on, no barrier, no cosmic gate. Only an invisible horizon beyond which the universe refuses to reveal itself. It feels as though reality has drawn a curtain across everything that exists. For thousands of years, humanity imagined that if we could travel far enough, we'd eventually reach the end of creation itself. But modern astronomy has uncovered a truth that's even stranger than science fiction. The edge we see isn't the end of the universe. It's only the limit of how far light has been able to travel since the universe began nearly 13.8 billion years ago. Beyond that horizon could be countless galaxies, unimaginable distances, and perhaps an entire cosmos forever hidden from our view. And if that's true, what are we really looking at when we stare into the deepest darkness of space? Now, imagine turning around. The edge behind you isn't a wall, it's a view. Every galaxy scattered across the darkness, every distant star, every faint point of light is actually a message from the past. In space, distance and time are inseparable. Because light travels at a finite speed, nothing in the universe is seen as it exists right now. When you look at the moon, you're seeing it about 1 second ago. The sun appears as it was over 8 minutes ago. A nearby star might be decades in the past, while the most distant galaxies reveal a universe billions of years younger than today. The farther we look, the deeper we travel into cosmic history. Powerful telescopes don't simply look across space, they look back through time, uncovering chapter after chapter of the universe's story. In a way, the night sky is the greatest history book ever written, and every beam of light is a page that has spent millions, or even billions of years crossing the cosmos just to reach your eyes. But if every observation eventually leads us further into the past, how far back can we actually go before the universe itself stops us? Eventually, every journey into the past reaches the same destination. Beyond the oldest galaxies, beyond the first stars, lies a faint glow that fills the entire universe. It isn't a galaxy, a planet, or a cloud of dust. It's the oldest light humanity has ever detected, the cosmic microwave background. Nearly 13.8 billion years ago, the universe was so unimaginably hot and dense that light couldn't travel freely. Every photon was trapped inside a blinding sea of charged particles, scattered endlessly in every direction. The cosmos was completely opaque. Then, about 380,000 years after the Big Bang, everything changed. As the universe expanded and cooled, electrons combined with atomic nuclei, forming the first neutral atoms. Suddenly, light was free to move across space for the very first time. That ancient light has been traveling ever since, and today it reaches us as a faint microwave glow, coming from every direction in the sky. It is more than just the oldest photograph of the universe. It is the ultimate horizon of light. No telescope, no matter how powerful, can simply look beyond it using ordinary light. So if the oldest light marks the limit of what we can see, what was happening before light itself could escape? But the cosmic microwave background isn't the beginning of the story. It's simply the oldest light we can see. To uncover what happened before that moment, scientists had to rely on something even more powerful than telescopes' mathematics. Their calculations point to an extraordinary event that occurred in the tiniest fraction of a second after the Big Bang. It's called cosmic inflation. According to the leading model, the newborn universe didn't just expand, it exploded outward at an unimaginable rate, growing from something smaller than an atom to an enormous cosmic scale in less than a trillionth of a second. Surprisingly, this doesn't violate Einstein's theory of relativity, because nothing was moving through space faster than light. Instead, space itself was expanding. Imagine drawing two dots on a balloon. As the balloon inflates, the dots move farther apart without traveling across its surface. In a similar way, the universe stretched, carrying everything with it. That single event may explain why the universe appears so smooth, so flat, and so remarkably uniform in every direction. But inflation also leads to an astonishing possibility. If space expanded that quickly once, what if most of the universe was pushed so far away that its light can never ever reach us? Now we arrive at one of the biggest unanswered questions in all of science. If the observable universe is only the part whose light has reached us, then what lies beyond it? The honest answer is that nobody knows. But physics offers several remarkable possibilities. The simplest is that the universe continues far beyond our cosmic horizon, filled with countless more galaxies, arranged much like the ones we already observe. If that's true, what we call the observable universe would be just a tiny neighborhood inside something vastly larger. Some cosmologists even suggest the universe could be infinite. If space has no edge and no end, then no matter how far you travel, there would always be more stars, more galaxies, and more cosmic history waiting beyond the horizon. These ideas aren't wild fantasies, they are mathematical possibilities supported by observations that show space appears astonishingly flat on the largest scales. Yet no telescope can confirm what lies beyond our observable limit. The universe has given us clues, but it has hidden the final answer behind a horizon we may never cross. And that raises an even stranger possibility. What if our entire observable universe is only one tiny region of something far, far greater? One of the boldest ideas in modern cosmology begins with a simple question. What if cosmic inflation never truly ended? Some physicists have proposed a theory known as eternal inflation. In this model, while inflation stopped in our region of space, allowing stars, galaxies, and eventually life to form, it may still be continuing elsewhere. As inflation slows in one area, it creates a universe like ours. But beyond it, space keeps expanding, giving birth to other immense regions, each separated by distances so vast that no light could ever travel between them. These regions are often called bubble universes. It's important to understand that this is not an established fact. No telescope has observed another universe, and no experiment has confirmed its existence. For now, eternal inflation remains a serious scientific hypothesis, one that emerges naturally from some mathematical models of the early universe. If it's correct, then our entire observable universe could be just one tiny bubble in a far greater cosmic landscape, surrounded by countless others forever beyond our reach. It sounds like science fiction. But for many cosmologists, it's a question that mathematics refuses to ignore. Just when it seemed the universe couldn't become any stranger, it did. In 1998, two independent teams of astronomers made a discovery that shocked the scientific world. By observing distant exploding stars called Type Ia supernovae, they expected to find that the universe's expansion was slowing under the pull of gravity. Instead, they found the exact opposite. The expansion of the universe is speeding up. Something invisible appears to be pushing galaxies away from one another faster and faster. Scientists call this mysterious phenomenon dark energy, but the name isn't an explanation, it's simply a label for something we still don't fully understand. Today, dark energy is estimated to make up nearly 70% of the total energy content of the universe. As space continues to expand at an accelerating rate, more and more distant galaxies will eventually move beyond the observable horizon. Their light will never reach Earth again. In the unimaginably distant future, civilizations may look into the night sky and see only their own galaxy, unaware that billions of others ever existed. The universe isn't just expanding. It's slowly hiding itself from us. And if the cosmos keeps erasing its own history, what will be left for future observers to discover? So, what lies beyond the edge of the observable universe? The most honest answer science can give is beautifully simple. We don't know, not because we've stopped searching, but because the universe itself sets a limit on what we can observe. Beyond that horizon, space may continue for trillions of light years. Perhaps forever. It may contain countless galaxies almost identical to our own, or regions so distant that their light will never reach us, no matter how long humanity survives. And that's what makes this mystery so extraordinary. For the first time in history, we've reached a question where imagination must give way to evidence. Every telescope we build, every spacecraft we launch, and every equation we solve pushes that boundary a little farther. Yet the greatest part of reality may always remain beyond our sight. Perhaps the edge of the observable universe isn't a wall that marks the end of existence. Perhaps it's a reminder that knowledge itself has a horizon. Some mysteries are waiting to be solved. Others exist to remind us how much wonder still fills the cosmos. And somewhere, beyond the oldest light we've ever seen, the universe continues its silent story, whether anyone can witness it or not.